Hello everyone, welcome to Engineering Archives. Let us look at practice problem number 3 for this chapter. So this question says, express the force Fb and Fc in Cartesian vector form. And the second part of the question is, determine the magnitude and coordinate direction angles of the resultant force acting at A. For the first part of the question, we have to express this force vector from A to B in its Cartesian form, and also this other vector from A to C in its Cartesian form. So let's start with that. As you can see, this diagram specifies the length measurements for these two force vectors, and we can use those to find the length vector r for these two force vectors. So the process that we're going to go through to find the Cartesian forms of these two force vectors is, first of all, we will find the length vectors for both of them. And once we have got those length vectors, we will use those length vectors and find the magnitude of those vectors, and using that we will find the unit vectors. And once we have our unit vectors, we can simply multiply the unit vectors with the magnitude of the forces specified in the question, that are 600 Newton and 450 Newton respectively, and we can use those to find the force vectors. This is the general procedure that we have been using in the previous questions, and we will use the same procedure for this question as well. So let's start with the first force vector, that is Fb. So first of all, we will find the length vector from the point A to the point B. So to find this length vector, we need to look at the component of length in the x, y, and the z directions. So in the x direction, we can see that this vector goes from the point A to the point B and travels 0.5 meters on this side of the y-axis, while it travels 1.5 meters on that side of the y-axis, which means it travels a total of 2 meters in the negative x direction. So we will put negative 2i. Next, we look at the component of the length in the y direction, and we can see that the vector travels 1 meter in the negative y direction. So that means the second component is going to be negative 1j. And lastly, in the z direction, we can see that the force vector, or the length vector AB, travels 2 meters in the positive z direction. That means the last part is going to be plus 2k. So this is our length vector from the point A to the point B. Now that we have our length vector, we will use it to find the magnitude of this length vector. So we will use the magnitude formula, that is under root sum of all the components, sum of the square of all the components. And once we solve this, we get 3. So now that we have the magnitude, we can use this to find the unit vector from the point A to the point B. And the way to find the unit vector is divide the length vector RAB by its magnitude. This gives us negative 2 by 3i, negative 1 by 3j, plus 2 by 3k. So now that we have our unit vector from A to B, we can multiply this unit vector by the magnitude of the force from A to B. And this magnitude of the force is given in the question right here, and this magnitude is 600 newtons. So we will multiply 600 newtons by this unit vector. 600 multiplied by the answer that we get is negative 400I minus 200J plus 400K. Now we will repeat the same procedure for the next force from point A to point C. So first of all, we need to find the length vector from the point A to the point C. From the diagram, we can see that this vector travels 2 meters in the negative x direction. So we're gonna have negative 2I. It travels 2 meters in the positive y direction. That is going to give us 2J. And lastly, it travels 3.5 meters in the positive z direction. And so that is going to give us plus 3.5K. So now that we have our length vector, we will find the magnitude of the length vector using the same magnitude formula. And we get 4.5. Now we can find the unit vector from the point A to the point C, and dividing the length vector by its magnitude, we get negative 4 by 9I plus 4 by 9J plus 7 by 9K. Now that we have our unit vector, we can find the force vector from the point A to the point C by multiplying the unit vector by its magnitude, and that magnitude is 450 newtons. So 450 multiplied by the unit vector that we found. So I'm not going to write that down. I'm going to simply write down the product, which is going to be negative 200I plus 200J plus 350K. So this is FC. Now that we have our two forces, we can proceed to the next part of the question. The next part says, what is the magnitude of the resultant force and what are the coordinate direction angles? So to find the magnitude of the resultant force, we will first need to find the Cartesian form of the resultant force. And to find that, we can simply add up the Cartesian forms of the two force vectors that we just found. So we need to add FB to FC to get our resultant force. So the resultant force is going to be negative 400I, negative 200J plus 400K. So this force FB added to the force FC, which is negative 200I plus 200J plus 350K. So once we add up all these, we come to know that the y components cancel each other out. What we are left with is negative 600I plus 750K. So this is the Cartesian form of the resultant vector, and we can find the magnitude of the resultant vector by using the magnitude formula, which is the sum of the squares of each component. And we end up with 960.5 newtons. So this is our magnitude for the resultant force. Now let's move on to the last part of the question. For this part, we have to find the coordinate direction angles. So we see from the Cartesian form of the resultant vector that our resultant vector only has components in two directions, that is, in the I direction and in the K direction. So let's find the angles that the resultant vector is going to make with the x-axis and the z-axis. So we will use the coordinate direction angle formula. Cos theta x would be equal to the component in the x direction, which is 600, negative 600, divided by the magnitude of the resultant force, and that magnitude is 960.5. Solving for theta x, we get 128.7 degrees. And similarly, we will do the same procedure to get the angle that the resultant vector makes with the z-axis. So cos of theta z is equal to the component in the z direction divided by the magnitude of the resultant force. Solving for theta z, we get 38.7 degrees. So this was the lengthy procedure for this question, but you will notice that all the steps that we did are the same steps that we used in our previous questions as well. So there wasn't anything new in this question, although there were a lot of parts to this question, and so it is good practice to do big questions like these. Thank you very much. See you in the next video.